computer. All right. So, hi everyone. Thanks for joining today's seminar series organized by the Empathic Computing Laboratory. I'm your host, Pai, and our guest speaker for today is Kunze, who is currently a professor at the Graduate School of Media Design at Keio University. He was actually my PhD supervisor last time. And his research interest is mainly about wearable computing. So the title of this talk is about AR/VR HCI, Augmenting Humans, which will cover wearable computing, including smart eyewear, interaction techniques, body schema extension, embodied learning, and finally, sports and human augmentation. It will be about an hour, give or take a few minutes. And then later on, we'll have a brief Q&A session. If there's any questions, just raise your arm, not physically raise your arm, but just press the raise arm button on Zoom. And then you can ask a question from there on. So for your information, this talk will be recorded. It's currently being recorded and will be uploaded in the future later on in our lab's website. So you guys can just access that to share with anyone who wants to know more about it. Oh yeah, so there's a fancy new presentation way. I think I have to make you like spotlight video. Is it spotlight video so that you'll take up the whole screen?
Yeah, I think you can ping me.
Spotlight video. Oh, there you go. Yeah,
right.
It's like spotlight video.
There you go.
Okay, so without further ado, over to you, Kai.
Yeah, thanks a lot, Pai. Thanks a lot for inviting me. And it's also nice to kind of at least virtually visit your new lab. So for this talk, I'll try to give a little bit of an overview over things that I've been doing for the last maybe 20 years or so on. And at the end, I'll come to something new. I didn't also know that Mark and Philip and so on would be online, because for Mark, Philip, and Pai, it might be a little bit boring, because there's a couple of old works as well in there. But overall, a quick background on myself. So as Pai mentioned, I'm a professor at Keio Media Design, and since 5 years or so on, 6 or 7 years in Japan already, beforehand in Osaka. However, my research is not in media design, but in wearable computing. So I did a lot of work in pervasive computing beforehand, and that was kind of where all of the stuff started around the 2000s or so on. You see a younger version of myself just in the corner over there, and the first PhD project that I worked on, or the first work that I did during my PhD, was porting some software onto the Cubic. That was a belt integrated computer. For those of you not old enough, there was actually a time where we didn't have smartphones, so you had to wonder where to put wearable computing on the body, and kind of that was the first thing that we thought about, belt buckles. And I see nobody is now wearing belt buckles, but anyways, and then since that, working a lot with industry, even though always staying in academia, kind of stuff with the Paris firefighters, Skoda, SAP, Wembley Arena. I got more and more interested actually in what is going on in our minds or brain, and how can we detect that with smart or smaller sensors since the last 6 or 7 years. And there's also this overlap, I think, to the empathic computing, and I got a lot of inspiration from what Mark is actually doing, and it's nice to see then also the next generation. So Pai now then working also with Mark. Anyways, so this is the research group. This is an old picture. You see a younger version of myself, and also a younger version of Pai, actually. This is in our house temple in Kyoto. We have a monk also as a researcher registered with us. So we did a couple of retreats already there. And also for me, as a little bit of background, so I'm working my training is completely in computer science. However, I work in a design school. So this is on the bottom, just here. That's where I'm currently working in Hiyoshi. This is where the Boeing stuff is, campus and so on. We have also a Shibuya lab in in the center of Tokyo, where we tend to meet with companies, and I'll work with chins, and we also have a place in the Japanese Science Museum. So as soon as kind of this COVID situation is resolved or better, I hope kind of if you visit Tokyo, yeah, send me a message and so on, and we can meet up, and we can also check out the Mirai-kan, so the Science Museum, which is fun. Anyways, I'll get to the work with chins, but maybe a little bit of background to myself. Before I was looking into, I would say, augmenting humans, I was mostly working on physical activity recognition. And I think there's this long-term thread that goes through my research, where I was wondering, kind of, I was always interested in having technology close to our body. And then I realized pretty early on, kind of, you see a picture from Park Palo Alto Research Center and a picture from Passau, where I wrote my PhD, from my desks in the background. I realized relatively early on that if you're surrounded by computing, the limiting factor, the limiting performance factor, is no longer RAM, CPU speed, or some other characteristic, but it actually becomes human attention. Even if you have the slickest, most beautiful interface or user interaction with the device, if you have to configure 40, 50, or 60 devices in the morning after you wake up, that's just not going to work. And from my perspective, then the keywords were activity recognition and context-aware vision. So how can we make an intuitive cooperation between humans and computers possible? How can actually then also humans understand what a person is doing, and then just helping them in situ? And how that looked like, at least in around 2000, around the 2000s, was this is an example from a collaboration with Zeiss in Oberkochen, where we used a heads-up display and just-in-time information to help them do maintenance. Yeah, now the video is playing. So sorry for the bad video quality, but that's a quite old video. So in this case, you see a maintenance worker at a machine. He's doing a cabling error. He gets the error feedback on the screen. As soon as he resolves the cabling error, the error goes away, and kind of he can continue with the work. And kind of these were the type of systems we made, especially for industry at the time, because there you could really do this augmentation. I mean, you see he's wearing a quite clunky heads-up display, and we're using infrared markers to track his position at the machine and things like that. So, and that was kind of the complexity. I don't want to go into much detail, but that was kind of the complexity we were dealing with in terms of activity recognition. However, what I then saw in the last couple of years was that this activity recognition became more and more mainstream. On the left side, you see the we often call it Paul, my supervisor, Paul Lukowitz in the FKI now, before in University Passau, always calls it a Christmas tree setup. You put a lot of sensors onto the person to try to understand what they're doing. And some of those setups took 45 minutes, 50 minutes to wire people up to connect all of the sensors. However, kind of what we see now is that actually the accelerometers, the motion sensors, and other things that you have in your smartphones are much better than what we used 15 or 20 years ago for this. And then, kind of there are a couple of other problems then with that, but you see activity recognition, at least physical activity recognition, to become mainstream. And, kind of then for me, the question came up, okay, if that's mainstream, and if companies are working on that and doing tracking, and you can get, your smartwatch that tracks how many steps you do, if you're walking upstairs, if you're walking downstairs, and so on, what is next from a research challenge? And then I went towards, at the time I called it cognitive. I would now call it something like mind tracking, because I don't like the term cognitive too much, because it kind of feels, oh, there's this separation between physical and cognitive, where it is actually more embodied. But I started working on this, thinking about what kind of mind activities or cognitive activities could we track. And we started, this was in Osaka together with Koichi Kise, to track reading habits, at this time still with eye trackers, optical eye trackers. You see the SMI eye tracker in one of the pictures. So, infrared lights shine to the eye. You have a small infrared cameras that do pupil detection. You get the saccades and fixations out. And over this, we could figure out how much is somebody reading, and also what are they reading. So in this case, important for Japanese students, the differentiation between textbook and manga. And just by using the visual patterns of the gaze, and we also try to move towards how much does a person understand. We did some work to try to figure out TOEIC scores based on reading comprehension tests and similar things, but that was way harder, and there's still a lot of work done there. However, for me, being from the wearable computing field, actually the biggest problem I had with the setup was this is not really how we interact with the world or how our brain interacts with the world. This is, I think, from Nottingham University and UCL, the most wearable brain scanner you can get, magnetic resonance brain scanner right now. And I don't want to belittle the efforts those researchers took, because this is really groundbreaking. As you see, you can actually drink a coffee. You're not lying in a big tube and cannot move anymore. However, this is not really how we interact with the world. And there are more and more studies coming out that even for something like an eye tracker or Google Glass or also HoloLens, it really changes the social interactions. It really changes how people interact with you or how you are interacting with the field. If your motions are limited, and also if you're just wearing a device or wearing something that looks strange. There's work, for example, that shows from Jamie Ward, Goldsmith University, that shows that just the fact that you're wearing an eye tracker changes actually your eye gaze. So, and also other people seeing that. So for me, kind of one motivation was, okay, can I do something like cognitive tracking or tracking what is going on in your mind with more simple wearable sensors and also more unobtrusive sensors? And we did a couple of works on Google Glass. We used phones and tablets and so on for this work. And then I was lucky that now also 5 years ago or so on, I could start collaborating with Jins. That was also the glasses that I mentioned beforehand, on Jins meme. And you see them in the lower right corner. That's Shoya, also now a researcher in Germany, wearing the glasses. And now maybe what are they? So they're not, Google Glass, or they're no AR and VR glasses. Sorry, I have to disappoint you. For that, they are just sensing glasses, so they are also not a full-fledged computer. I should have some, but anyways, you see them in the picture. And they just have sensors. So they have a 3-axis accelerometer, 3-axis gyroscope in them, Bluetooth Low Energy, and some power. However, the more interesting sensor is the EOG, so electro-oculography sensors. These are in the nose pads, the 3 electrodes, more or less. And what they can do is they can detect your eye movement, especially if you're not moving that much. So you can detect, this is work from Shoya. It should play with sound, so you can detect eye blink and also the left and right eye movement if there's not too much noise. And what you can do with this is you can actually play really terrible games. So this is Shoya trying to play Flappy Bird. It's the hardest game you can imagine. That's why he also looks so serious, because every time you blink, you don't see the screen. Or more interesting, what we used it for is also detecting actually reading and also detecting talking. why talking works, I will tell you a little bit later. So how this works is more or less, usually you use 2 electrodes here and here to detect up and down movement, because your eye as a dipole has a positive charge in front, negative in back, or 2 electrodes here and here to detect left and right movement. What we are doing is we're using these 2 for up and down and these 2 for left and right. And what you can guess is also there's a little bit of cross chatter, because the sensors here are nicer placed. The left and right actually works quite well. So that's why it's also kind of easy to do reading detection and other things. Yeah, as a thing, I'm one of the meme academic reach out persons. So we're doing quite a lot of academic collaborations with the device, and that's maybe also the more interesting thing that I also show. I have this earlier. I should have actually this one beforehand that I also showed you earlier. Was we're working on the next version of meme, and for that we wanted to do a student competition on Eyewear this year at UbiComp in ISWC, which will just happen next week. Next to next, so 12th of September. Actually, registration is also quite reasonable for students, so, or also in general. So if you find some interesting sessions and so on, please join. We wanted to organize a student competition, however, because the next version of meme is not released, and also because of the COVID situation, we postponed this. So we'll do that next year. You will get 2 Jin's meme if you're selected, and you should do something on interaction beyond the individual. And if you're interested, ping me also later about that. So then for, kind of things that you could do with Jin's meme is, for example, we did a long-term fatigue study. So in this case, we were looking into eye blink, especially eye blink patterns, for 16 participants over 2 weeks. So they wore the device for at least 10 hours. We recorded the eye movement. So especially in that case, we were interested in the blink. And then every 2 hours, they were asked from the smartphone, kind of how tired they are. So sleepiness scale and other tests, and also psychomotor vigilance task to do. So that's just fancy for a reaction task. That was quite an interesting study. That was Benjamin's work, who's now also in Australia as postdoc. And the interesting part for me was that we figured out that sleepiness scales questionnaires actually don't work, because the pre-studies we did with this just used the sleepiness scale. So we asked people how tired they are, and that was quite a bad measure for their fatigue over the day. It was not, it was just randomly distributed over the day with a slight peak of sleepiness at the end of the day, but really bad. And the psychomotor vigilance task, just measuring your reaction time for pressing a button, worked much better. So kind of as a takeaway message from that work was, if you can get some quantitative measurements that measure what you want to do, it's often better than questionnaires, especially if you're trying to assess something like fatigue, cognitive load, or the of those cognitive measures. So, the device is a little bit noisy, but you can still get decent data out of that. On this line of unobtrusive eyewear, there's also other work. There was also a collaboration with Mark on that. That's effective wear. So this was eyewear designed by Katsutoshi Masai, one of my master students. He built a device that could actually detect facial expressions using just a distance sensor in the glasses. This is the old version with 8 sensors, and it was just streaming the sensors to the PC that was doing the classification. So you have photoreflective sensors. And here the idea is, yeah, maybe cameras and so on work better, or are, but these ones are wearable. You can, they are cheap, and you can actually detect 9 different facial expressions just by the change of the skin in relationship to the distance to the sensor. So there's a little bit of follow-up work, and actually now I can try something. I wanted to show you the next version. Unfortunately, I wanted to show you a demo, but because of some other issues, that was not so. Wait, I can just maybe share the video. I think that should work. So, yeah, okay. So this is actually the new version of Effectiveware. And what is interesting here is we got the sensors to be much smaller. So I don't know if you see this on the stream. So these are bigger sensors, so 4 of them, because they have to, these are positions that you want to have a higher resolution. And then there are really tiny, smaller ones over here and here. They're quite hard to see. And it's an overall redesign. So we have a Wi-Fi board on this side, Wi-Fi and Bluetooth, and an Arduino on the other side. And now actually, I wanted to show you a demo. However, I can just show you the live streaming again because I somehow broke it. Oh, wait, I can just also share my screen. And this is now hard to do because you cannot see do you see the video? So if I'm moving over this oh, okay, no, live demo didn't. Oh, it has a large delay. Sorry, live demo didn't really work, but as a summary, oh no, it's, yeah, anyways, as a summary, so we're working on a new device. It will be able to do hopefully online detection of this in a wearable form factor. The only thing that you have to do then is you have to connect a micro USB cable for the power. So you have to wear an external power device. But overall, what we want to get is an easily wearable, Effectiveware glasses that record your facial expressions over the day. So there's older work from Masai also that was actually doing this. So this is a record over a couple of hours with different activities. So then you can really get, kind of how much smiling versus frowning you're doing, and maybe also do correlations over that for your daily activity. But that's that. So then other works that we're doing also with Eyewear is this is now a modified Jin's meme. And there's a couple of work that uses thermal and thermal cameras for the face to take a cognitive load. Here, especially, it seems the nose and this part between your eyes is actually interesting. Because it seems that if you start working on something, mentally, so if you start doing a calculation, or if you read something or something else, and and the cognitive load increases, what happens is that there's more blood flow to the brain, and that means there's a slight drop of nose temperature over here, and there's a slight increase of temperature over here. And that's something that we tried to model in the glasses. So what you see here is an Jin's meme that is has contactless thermal sensors attached, 2 pointing to the nose and 2 pointing over here. And in this case, we are continuing the study. We have a kind of a short work in progress out, but I'm really surprised on how nice that seems to work with the activities. So in this case, we did different activities to increase cognitive load, like a Stroop test and NBAC and two-digit calculation. And what you can see now on the graph, that's the relative temperature between the two. And dropping means that the nose temperature gets colder, and this one increases. So you see for the tasks that you always have a drop as soon as the task starts. Of course, that's in a kind of controlled environment, so we're not sure. This was really, kind of in a lab study with 5 to 6 participants. We did a couple of continuous studies, and it seems to still hold. It seems to look quite nice to detect something like cognitive load onset. However, due also to COVID, we couldn't do more studies on that. There's also a little bit of, not confidential, but it's kind of not published yet, is we have now a wearable version of this that can also record for a longer time during the day. And we're currently trying to do recordings with that as well. So then, kind of your smartphone, similar to the fatigue study, your smartphone is pinging you to do some type of cognitive load test during the day. And we try to detect these events in a semi-supervised fashion. Other works we are doing on the eyewear work is also we're looking into synchrony and interpersonal synchrony. So moving from, the individual, I would say, cognitive life towards something that is more on the social computing side. And in this case, we looked into eye blink and head nod synchrony when two people are talking to each other. And we could replicate studies from psychology that, kind of usually if you're talking, so also if you're seeing me, I'm not sure if it's over video working that well, but if you're seeing me and we're talking to each other, your eye blink and head nod will synchronize slightly with me and vice versa. And this is something then we could also show that we can use Jin's meme to just detect that in an unobtrusive setting, so you don't have to sit down and count the head nods or eye blinks as some psychologists did, or you have to use camera. In that case, we still use the video camera for ground truth and for the recording. However, later on you can just detect this type of synchrony also over the glasses. Here's an interesting finding that we haven't much looked into. So we're using continuous wavelet transform for the analysis. That's also, I think, something nice or something to look into if you're interested in synchrony, because if you're just doing a Fourier transfer or if you're just doing a frequency analysis, you might not really be spotting the synchrony because it might be slightly offset. And with this continuous wavelet transform, it actually works quite well. And we detect a nodding synchrony in a low frequency area and also the eye blink synchrony. What was interesting, and that's not published, is for this experiment, we had actually, I think, 42 participants, so 21 pairs or so on, or 22, so 44 participants talking about, what was it, you have to decide on a meal, 3-course meal, and with ingredients that none of you likes. So, kind of we try to get them discussing, because one of the requirements was also they shouldn't know each other that much on campus. So this was, of course, pre-COVID. And the interesting part is we got half of them were actually talking in Japanese and half of them were talking in English. We didn't really make that a requirement for our study or so on. And also there were non-native speakers in both groups. So we had non-native speakers in the Japanese speaking group and non-native speakers in the English speaking group. and also, you know, kind of different cultural backgrounds. And what we saw was interesting, that there seems to be a different nodding behavior for Japanese speakers. Especially what you see here is again the correlations, or the correlation coefficient. And what you see is, I think this is log period in seconds. So that means the area is about, this is a couple times a second. So this is really a quick nod where you get the synchrony. And that would be actually for the other participants, for the non-Japanese, you wouldn't see this type of synchrony. And one idea is that it really has to do with the language. So, you know, kind of there might be characteristic influence of the movements depending on which language you're talking. So not the cultural background, but really the language thing. And we have some ideas for later studies. I just wanted to bring that up because that's definitely something that I would like to explore later on, also with other studies. And I just thought it might be an interesting discussion point. And then, you know, kind of other works we're doing in smart eyewear is also we're moving towards interaction and subtle interaction design. And here there's one work together with Thad Sterner and also Aaron Quigley, so Yo and Jo Young Lee from KAIST were doing this. And this came up actually from a strange coincidence where we had Jo Young was visiting me for an internship, and he was also part of some of the pre-studies, the longitudinal studies for Jin's meme. And what we figured out was there was really a strange noise on his data for Jin's meme. And we wondered why that happened. And actually, he was just touching his face very often. So he recorded himself then sometimes. And then we recognized that we could actually also do face touch detection. And in that case, that's probably no longer a good idea if you're thinking about COVID. But in that case, we actually then did some face touch gestures also based on Jin's meme. And you can see here like the different things that you can detect: flicking, pushing, and also rubbing. And some ideas for interactions. We're ignoring a phone call, or also you can also browse your email and delete it while in a room with another person. Why I bring that up now is we're looking into that actually also right now is you can also detect some face touches on Jin's meme because you get noise on the electrodes, and depending on, especially if it's upper lip or nose, you can also, or it should be possible to detect that. And that could be also interesting information if you're thinking about face touch detection. It might not be enough on its own, but seeing, you know, kind of there are some people that implementing face touch on a wristwatch or so on, it might be also quite an interesting thing to look into. So, however, now moving over, you know, kind of, we did quite a lot of work on the eyewear, and I still think eyewear is an interesting sensing and interaction modality. Also seeing now that, you know, HoloLens 2 was just released, and also it seems Apple and others are also still working on new eyewear, and it's just a good position to use or to have sensing and interaction on the head, because you directly have access to a lot of our senses. However, in the recent years, I'm getting more and more interested in really how to bring technology closer to our body, kind of going back to the roots. You know, I thought really that in 10 or 15 years, when I started my PhD, everybody would have their one-handed keyboard and head-mounted displays and so on, and that really didn't happen. And I think, you know, after trying out a lot of those devices, I could also understand why that didn't happen because, kind of not everybody is as crazy in place, kind of, or takes so much time to set up their environment in a way that they can use it. And I think except of Thad Sterner, who's just next to me right now, nobody really uses a wearable computer every day. And also Thad's interactions are sometimes strange because, you see him with his Google Glass and his Emacs mod that he has running on there. And then if you say something interesting, one eye will look at you, the other eye will look up on the head-mounted display, and then he uses his one-handed keyboard to type in things. And now I'm still interested in, kind of, can we make that less, or can we make that more socially acceptable? And also, how can we really use technology and digital technology in a more unobtrusive sense? So, kind of current buzzwords that I'm interested in, we can talk also about this later on in the Q&A, is, empathy and agency and ownership, and also extending our body schema, and then making wearable really overlap with our body. Here we had a paper out. Oh, I forgot to share that. I have the slides as well as some additional material on just the Google Drive, so you can also access that. And we had just also a paper out with, I think, 40 co-authors. It was from a Darkstuhl seminar, Next Steps in Human-Computer Integration, where we're trying to outline a little bit on, there's also a bit.ly address that's maybe easier. Here the slides and also the some of the papers where we try to outline, what is necessary, what will need to come together. So not looking into human-computer interaction, but looking more into a human-computer integration. I really don't like that term. I prefer much more augmented humans, but maybe we talk a little bit later about that. But if you have 40 co-authors, it's kind of hard to press on that. But I'm interested in this idea of integrating devices closer to our body. And in that case, I don't really mean implantable, although that might be also interesting, but I'm not really doing medical science or medical research. However, I mean really that they feel more like being part of our body. And, kind of small works, this is collaboration with Caro Maki from TU Darmstadt, with also in this year's Kai that goes a little bit into that direction, but is more on the tangible side. Is, you could use your muscle memory for something like security or two-factor authentication. So in that case, Caro built or made small 3D printable objects that you can use for two-factor authentication. And for me, kind of, you have conductive dots, and depending on how you turn or how you interact with the device, that would be then your second factor. And I find it interesting from an aspect, not this kind of basic implementation here, but what I really find interesting, this idea of using muscle memory as a part of security in that case. So the muscle memory on how to use a device could be your way of then remembering or interacting with it. I mean, maybe more, kind of towards something that is then also haptic and more active than instead of just 3D printing. That's a work from George, where we used actually muscle wire, so shape memory alloy. It's basically a thin wire. You put it with 3 rings around the finger, and if you apply current, it shrinks. So then you get some pressure on the finger. And what we basically built was a progress bar on the finger. And here you can see how well 20 people perceived an actual number between 0 and 100. So the error is relatively low. like 15%, 10%. So you can easily represent the progress bar on the finger. And the nice part about the haptics is, you don't get a notification, you don't get visual attention taken away, and you have a kind of a subtle feeling for, how far are you on your travel on the train, or how much money is still on your credit card by just putting the finger on it. So this is kind of the idea I have when I'm talking about integrated. We did also more crazy work. That's work also from George and Kirill, where they enhanced the horror experience. This was part of SIGGRAPH, the immersive pavilion this year. Unfortunately, we couldn't really show the demo because the demo is really cool. It uses eye tracking, so it uses pupil dilation to detect your stress level, and then Peltier elements, so hot and cold on the neck and also on the arm. They implemented it with water cooling, so then you can quickly change. The hot and cold feeling, and also can stimulate something like pain, especially if you alternate it. And it's a kind of a Japanese horror house scenario that you walk into in VR, and that works quite well together with sound and the thermal feedback. You can really create scary experiences and bringing, kind of then also VR closer to you. There's some other work in the social interaction that's also confidential that was accepted at VRST. So paper should be out pretty soon. If you're interested in this, Pi knows much more than I do, but this is kind of enhancing face-to-face interaction by enabling facial feedbacks, or especially eye looking at each other using several displays around HMD and 360-degree vision. So talking a little bit about maybe the future of social communication enhanced over technology. And then, moving over to something like editing the body schema. So this is also older work from an augmented human demo. We have a new conditionally accepted new paper on this. This is the unconstrained neck. In this case, you have a camera on top of you, and you can actually move. You are in an AR, in quotation marks, environment with a headset, and your range of vision is usually limited to around 200 degrees plus minus 160 or 180 binocular. And with this, we relieve you from that. You have a 300 degrees neck movement. We show also in a task that you're quicker in a pointing target task. But the interesting part for me is actually, if you try the system, is how seamless it is and how little you recognize that you actually have 360-degree neck movement. You move your head left and right, and you just don't really feel that after being in the system for a bit. There's a little bit of a lag in terms of the motor, but if you get used to that in a couple of 10, 20, or 30 seconds, it's quite seamless how well this is integrated with the body. There's also other work where we explore how tech can overlap with the body. This is also a collaboration with Minamisawa Sensei Meta Arms that was at WIST last year. And in that case, we're doing a remapping, or actually Yamen and Tomoya are doing a remapping from the feet to 2 additional arms. So you do have 2 additional robot arms behind you, and then you can move those 2 additional arms while using your legs. And for me at the beginning, I was not so much interested in the system because I'm not so interested in the robotics. However, when I tried this was at SIGGRAPH, a previous version of the system. It was fascinating to me that after 20 or 30, I know at the beginning it was longer. So at the beginning it was maybe 10 minutes, 15 minutes. I really had the feeling of having an additional arm. This is Tomoya, and this is just for advanced users to try to solder, but he really is soldering with it. And so for me, the interesting part about this system was that after a couple of minutes in the system, you really had this feeling of having a third or fourth arm. And it didn't feel like moving your legs anymore, especially for some of the Fitts Law studies and other things. We had a table just in front of the person. And if you block the view of the feet, it's actually, kind of even working faster. And I felt that was also interesting. So how can we give a person a feeling of having an additional limb or work? Along that line, we are also exploring artificial muscle, and then what Takashi, who worked on this, coined artificial muscle memory. So in that case, we're using pneumatic muscle to move your hand, and we can do more or less flexation, extension, pronation, supination. So we can do at least 4 different movements. And in that case, we tried to use that to program you to learn percussions, to learn drumming. That was an Augmented Human paper. We compared giving you the rhythm over the artificial muscle versus learning a drumming piece over audio, and we could show that you're doing less errors, you're learning faster if you feel that on the body. I think kind of these 2 works they resonate quite well with a lot of other research that is done in a similar fashion, showing the embodiment. And now for the last part, how am I with the time? Yeah, I try to finish up early, I think. The last part, I want to think more about the collective experience. So moving away from individual people to something that maybe, a group of people can experience together. And in this case, we worked with a dance performer, say here in Tokyo, Mademoiselle Cinema, and this is also a collaboration with Minamisawa Sensei, so professor also at Keio Media Design as the previous works as well. And in that case, we tried to bring the people or the audience more to the stage. So looking into how can we integrate the audience and maybe the physiological signals from the audience in an art performance, in a dance performance. And what we did was we did a couple of pre-studies with predetermined dance performances and so on. However, then we started designing together with Mademoiselle Cinema, so with the choreographer of the team and the dancers, a piece where you have a visualization, where you have audio, where you have also lights that change based on physiological data of the audience, and the dancers adopt based on those changes. So the whole piece then was designed in a way that we make the audience and the physiological data from the audience as part of the performance. And so we had, luckily, before COVID hit us, 3 performances with around 40 visitors, and we recorded. Oh, I'm in the way. So in the loft, you see the setting where each visitor actually got then heart rate and electrodermal activity sensor. So we used the fingers. We used we tried several of the ones that you can buy, like the Affectiva and so on, and they didn't really work well for us. So we built our own system to stream the data, and we used also the fingers, because especially galvanic skin response, and if you want to go for heart rate variability, the wrist just didn't cut it for us, for most people. And we recorded and streamed the data and had these 3 performances. And unfortunately, this is not published yet. There was a little bit of news coverage also in Japan. And of course, these were public events, so kind of people know about it. So I think it's okay to talk about it. And as soon also, if somebody's interested in the data, I'm also happy to share, or kind of hook you up with the people that work on it. So that is Moe and Karen, two of the students or two of the researchers in my group. And here's a small video to give you an impression of the performances. Yeah, I think you got the idea. So the interesting part, I think, also for me for this piece was really that the projections, the sound, as well as also the lighting, changed based on audience physiological data, that in turn also then changed, of course, the dance performance. And we kind of could create a type of a feedback loop in this sense for the 3 recordings. That's about yeah, I have a little bit, but yeah, that's more on the side of nomenclature. I have a little bit on augmented humans and superhuman. So kind of, I think a lot of the work touches AR, VR, and I think also a lot of the things that I see from your lab. And I'm very interested in augmented humans, and I think I also like that term. There's also, Superhuman. So I'm part of the Superhuman Sports Society. We try to organize this year another event in Tokyo for the Olympics, but because the Olympics got postponed or so on, that's not happening. But for me, it's a nice way to try to test, or kind of this type of art and sports performances are for me great opportunity to test technology before kind of they can be implemented maybe in a larger application case in society. I wanted to give a small shout out to this because, you know, there might be also some people interested in doing another Superhuman Sports Design Challenge if everything works well. This was, we had one in Delft. We wanted to organize one this year in Tokyo. The Delft one was organized by Stefan Lukos, who's now also working at HIT Lab in Christchurch. So you have, you know, kind of also somebody who's really great to collaborate with on these type of works. It was really amazing how well he organized and kept things going. And I like this idea because also for the dance performances and for the other works, I really think, you know, for some technologies, you really have to try them out. So for Delft, what Stefan and me were doing is we had one day of just an academic program, but then the other 2 days were actually, we had big space where the public was also invited to try out the different sports. And I think that's something, you know, kind of, especially if you're working on VR, AR, or also augmented human experiences, that's something that's just a must. So that's about it. Small shout out at the end to the people that actually did the work, and yeah, also again thanks for Pi for inviting me, but also thanks to Pi for contributing to so much, also to our research at KMD, and, you know, kind of continue to do that over collaborations. And yeah, 2 shout outs again. So next year we will have a student competition on Eyewear. And also, yeah, augmented humans, important is the S, will be next year in February in online and also in Finland. Deadline is 15th of November. And I think there's next year also a small conference in Yokohama called Kai. So I hope till that time, everybody of us can travel again. And I'm happy to have you over also for a talk or so on, or also contact Pi, because I guess we will try to do some workshops or so on around that time as well. Okay, thanks a lot.
Thank you very much for the presentation, Kai. It was amazing works that you show here. I hope the participants are not overwhelmed by all the demos. So yeah, we are now open to questions. So if you have any questions, just raise your hand and I'll just unmute you and I'll call out your name. Or if you're feeling shy, you can just type it out in the chat and I'll just read out the questions. I'm sure you all have a lot of questions, right? I don't want to do all the asking because I do know a lot of the questions. So we have one from Haimo. I'll just unmute you.
Yeah. Oh yeah, thanks. Hi, hello Kai. Thank you for the talk. It's very interesting. So I'm interested in the technologies for EOG, and when I think about EOG, it senses the signals from the muscles, the electrical signals. And when I look at similar things, that's electromyographies that senses bigger muscles. And I realized that the EMGs are kind of sensing the muscle signals. And there's another way to kind of actuating the muscles by sending the signals, the electrical signals to it. That's like EMS, electrical muscle stimulations. So I'm wondering, are there any like crazy research or technology that basically by stimulating through these electrodes that kind of forces our eyes to close or forces our eyeballs to kind of rotate to certain directions?
There was, yeah, so I tried actually a little bit. So that we had, what is it? We had one short paper. So what we tried is, I think we had a short paper at Augmented Humans, also Takashi Goto or so on. What he tried was, we tried to stimulate actually facial expressions. So that was more related to effective wear. So we thought, oh, you know, if we detect that you're not smiling enough during the day, what happens if we just, you know, kind of set you to smile? No, the idea was more on this level of, what is it, a James Lang theory of emotion, that, oh, if you smile more, you know, it's not only that something good happens to you, so I give you a present and then you smile and then you feel happy, then you smile, but it's also a little bit the other way around. The more you smile, the happier you feel. So we try to stimulate a little bit on emotion using EMS in the face. And yeah, EMS is quite tricky in the face. So for anybody, I don't recommend that to try out. So if you want to stimulate at least the lower muscles here, you can stimulate over electrodes on the side here. And depending on how you put it and how many, kind of, depending on the person, you will stimulate different muscles, and you can kind of figure out to get the right muscles for a smile or for other things. Around the eye, I wouldn't recommend it. I tried it for closing, for eye blink. And for that, actually, the problem is I saw flashes on my retina, and then I thought probably not the good way to do this. So EMS in the face is kind of tricky. There is work from, there was a UbiComp paper from, what is his name? Microsoft Research. Pi, you should know him. Crazy, I shouldn't say crazy. Microsoft Research.
Well, I remember
he did also the suck robot, the robot that walks on you.
Oh, that one. That was at WIS 2016, wasn't it?
Yeah, right. And what he did is I'll try to find a reference. Damn it, I can't remember his name right now.
Is he Japanese?
No. He's I think originally from Russia. He's now in the US. He works for working for Microsoft. Not sure where he is now. He was working with Christian Holz at the time. So if you're searching for Christian Holz and what they did is they tried to stimulate blink. So they used different technologies to stimulate blink in a UbiComp paper. And I felt that was quite interesting. So they also thought EMS, but then, kind of out of the same limitations, they didn't even try EMS. They tried pointing something towards the eye and also light flashes and so on. And they showed, I think AirPuff was the best to get your eyes closed. But I find these are quite difficult to do. If you're interested in, so there's work also from Jun Nishida. He's now with Pedro Lopez's group in Chicago. He has a nice system to do electromyography and also EMS at the same time. And he describes that quite well. And he would be also the person to ping for something if you want to do sensing and activation at the same time. But I would recommend not to do that in the face. And also the other thing is also, I mean, of course, Jin's meme and the EOG is also measuring muscle activity, especially for the blink. However, actually what you're measuring is the dipole of the eye, or what you're trying to measure is the dipole of the eye that is moving. But sometimes, of course, it gets the muscle movement is too strong. So, for example, for the blink. Hope that answered a little bit.
Yes, thank you for sharing. That's very interesting information.
We'll be probably we might be inviting Jun Nishida for the next seminar talk as well. So we could see you next time in the future, hopefully. Yeah. So we have a next question by Philippe.
Yeah, hey. Hey Kai, you talked about the SMA wire idea. So did you continue on that? Or how did you decide on using the finger?
So we continued on that a bit. For the SMA, the problem is a little bit, so you saw also, there was a glove. There's a reason for the glove, because SMA can get very hot. And also, at least the voltage that we worked with at the time was a little bit high. I can't remember, but that was quite a problem. Right now, we continued on that, and unfortunately, it's a rejected ISWC paper. No, it's the rejected. What was it first? I don't know. IEEE VR, and now also ISWC. Yeah, right. Where we used SMA springs. And they work quite well to give haptic feedback on the fingers on touching. That's actually also work with Pi, that Pi is heading. And however, nobody really believes us that it works. I know that it works, but I don't really know why it's so, kind of. The problem with SMA is, however, if you, also for that, if you activate too often, of course it shrinks together. So also for the spring, it will shrink. So you have to have something in that case. What was it? We could activate every 500 milliseconds to a second. and then not longer than maybe 10 minutes or 15 minutes or so on for that activation. So it's a little bit of a problem of cooling. So if you have, in this case, we used fans, or Takuro and Pi, actually, I should say, because I'm just, kind of giving a little bit of advice. I used fans for that. But if you would use something like water cooling, you can activate quicker. For something like the progress bar, it's easier because then you don't have to activate maybe for such a long time or so on, and you can just activate and wait. So
it's mostly for slow interactions then.
It's for slow. It's for So that's the thing. It can act quite instantly. So you get the pressure feeling quite instantly. However, you cannot, kind of when you are activating for a longer time, that's a problem. Or if you want to activate a couple of times afterwards. So that's a little bit the issue. So you should have a couple of seconds of cooling or something in between for that. And I think for me, what is nice about the SMA is we have also now a glove type. You can just, it's very easy to use, and it's very unobtrusive in a sense of it could be integrated into textiles. But the problem then is it can get very hot depending on which SMA you use, and this type of the property of the material that if you kind of put current onto it, it will shrink and will get hot. So you have to kind of cope with that in the design.
Yeah. And currently you do the attachment by gluing it, right? I've actually read the paper and I wasn't so sure, or glanced it, but
so it's glued, and in that case we use wires as an attachment for the fingers we use strings that are not SMA, and the SMA is in the back. So then you have not this trouble with the heating directly on the finger.
I see. Cool. Yeah. Thanks. I have a second question, if this is all right.
Yeah.
Actually, on the arts and performance thing, I think we talked about this, right, when you visited Freiburg, like on something similar, I think. So I've been continuing working with this artist as well, but I think for me it's sorry.
Oh, cool! Because that's also something I wanted to ping you about and see. Because now actually we have now a setup for stream, as you saw. I mean, we have now a setup for streaming. In the pre-tests, we actually also used Jin's meme, but because of the COVID situation, and when we did the other 3 experiments, we decided not to use Jin's meme, so nothing on the face.
Yeah, I think it's going to be tough to test those things. But what's your take on I think as well, it's a really good test for the technology, but what's there to learn from it beyond that? I think I'm still having like kind of troubles. I mean, it's a nice gimmick, right? So it's kind of an art simulation, but yeah.
It was fun. No, but I mean, as you saw also, I mean, that's why I try to, I mean, it's hard. So I wouldn't say, also for the talk, I kept it, kind of a little bit lightweight, and I didn't go too much into details and just an overview, and just showed a little bit of crazy things. And I think for me also the theater performance is something, that's more on the explorative side. But for me, it's interesting to think over the individual. So, David Gordon was doing also this work where I haven't seen much in continuation on looking at not at the individual in terms of wearable computing or sensing, but really looking at the interactions of people and what happens. There are some things that we see now for the theater recording that is interesting. I had actually the plot there, but I didn't really want to talk too much because that's also kind of ongoing. We're trying to currently publish a paper on that as well, or trying to write up a paper on that, and looking currently into the data. But so, for example, for the EDA, you can really detect the interesting events during a theater performance over the audience. So, what you get is there's one scene where the dancers run up to the audience and give them business cards. So kind of it's a Japanese thing, and in that case you see that, you know, as a spike in the heart rate as well as in a spike in the EDA or so on. So these are some things. There's also there are some other works, and I'm slowly getting interested in this Synchrony work. There's a lot of work in social neuroscience and also psychology about Synchrony. And there's, you know, kind of, yeah, there's Eyewear and not Synchrony. There's also for theater performances, Daniel Richardson's work from UCL that shows that there's a heart rate synchrony in the audience. For these pieces. And I find it interesting. I don't know, you know, I also, you know, have to tell you why are you doing this, or what is the overall point for this. I find it interesting and fascinating that you can see this in the signals. And I like this idea of, you saw for the 3 performances also very different performances based on these feedback mechanisms. And I try to explore more on these feedback mechanisms. On a research side, I think Synchrony is really interesting and also a little bit underused or under-researched. There's, I mean, Pi is also now doing work on the hyperscanning that I find fascinating. And I think there is something there, but to put it on an application case or so on, I don't know.
Yeah, it's
honestly. So yeah, it's still quite open. And I feel for me, it's just interesting. So now we have the opportunity to really record unobtrusive data on the large scale side. And I try to want to put out these research data sets and then just see, you know, kind of what can you learn from them. And what can you do with that? And, you know, kind of on a sense of also for virtual performances, actually now what we're thinking about is, you know, kind of sending out maybe those wristbands to people and try to do, you know, a virtual, the Mademoiselle Cinema already does virtual performances, you know, kind of just streaming, but of course they don't get any feedback. So now we're wondering, can we actually use that also for some feedback? But I agree, you know, kind of on a research question side, I'm not sure, except of the, you know, yeah, it's interesting and it's fun, and it's just yeah.
There are quite a lot of technical things, but yeah, I see it. Yeah, cool.
I had a question as well, Kai. I was really interested in your dance work, where you use the audience physiological cues to provide feedback onto the stage and the environment. What was the response from the audience? Did you talk to them afterwards and see how they, you know, if they felt more engaged with the dance piece, or, you know, more involved with it?
Yeah. So this is a little bit tricky. So we did 3 or 4 kind of tests beforehand, also with streaming data, also from Meme. The audience itself, we had questionnaires for the audience for all of the 3 performances, and, you know, kind of, yeah, everybody liked it and thought it was interesting, but, you know, kind of to see how it compares to a normal dance performance, that's actually quite tricky or difficult to say. Some said, yeah, they enjoyed it more than a normal dance performance, but these were also people that usually don't visit so many dance performances or, you know, kind of performances. So what I found interesting, however, was some of the feedback, and that gave me to think. So for the visualizations, that was mostly Kota's researchers' work. So Taichi and Moe were working on that as well. But we worked closely with the dancers, and we worked closely with the choreographer together to figure out how to do that. And however, the fascinating part from the audience feedback was that they found, so we had one scene, this was actually this business handout scene, where we showed the raw signal that was also quickly seen in the video. So we had 40 audience members wired up, and then we show actually in between at the beginning to just check that everything is working or so on. We have that on, and then in between for this one scene, we also have the raw signals. And some audience members for each of the 3 performances actually said, oh, they really like to see the raw signal because they could recognize individual people getting the meshi, getting the business card, because suddenly you see the spike in the EDA and heart rate data. And they could kind of try to associate that with the the person sitting there. And that was something I found interesting. So it seems, at least for this type of visualizations, maybe we don't have to provide too abstract visualizations, because that was also one comment. Like, one was, oh, they really enjoyed the piece and they found the visualizations interesting, but they couldn't really detect how they are represented in the visual. You know, when we saw the 3 recordings of the performance, we can recognize the different mood of the audience in the visualizations. But if you're just sitting in one performance, it's actually very hard to do that. So I don't know if that answers your question, but I felt that this observation was quite interesting. For the others, I think what will be possible is to detect interesting scenes, because we asked them, you know, oh, which was the most memorable, which was the most, you know, kind of the scene that you enjoyed most. And these correlate strongly with the EDA signal. So you can detect, I think, the most memorable scenes from the EDA. But for other feedback, yeah, I'm hesitant, because on this question of, yeah, they said they enjoyed it more than a normal dance performance, but actually I think what we need to do is, or what we should do to really compare that, is to have a pre-recorded dance performance where there's no, you know, kind of interaction, and one where there is actually some interaction to do that. And for that, Mademoiselle Cinema is not so much interested in that. So that's one of the troubles working with artists.
It sounds like you need to do some more evaluation, but the being able to associate the physical cues with the remembering of which parts of the performance they really enjoyed, that sounds really interesting. And I guess you could probably use the Ginsbeam glasses to look at different eye patterns as well.
Yeah, so for this, actually, for the 3 performances, we didn't have Ginsbeam. We had some for the previous ones, but that was, yeah, that was actually also my idea. The interesting part there was also due to some issues. So they had a questionnaire afterwards, but there was an online question. We asked them to fill out an online questionnaire. Most people filled that out 2 or 3 days later, and we just got 40 people in total. So we have 40 people per show, and then we had 40 people over the whole 3 shows, and then we asked for the memorable scenes, and they correlate strongly with the EDA. So that's something that I think is quite cool from the results.
Great, thank you.
Yeah, thank you
Thanks.
for the replies. I suppose we have time for maybe one last questions from anyone. Maybe Kunal, I'll unmute you.
Hi, Kai. Amazing presentation. So I have the question, one question about the enhanced VR experience for the SIGGRAPH demo that you had. So what kind of physiological signals were you using in that particular demo to recognize the emotion there?
So
scared emotion.
Not so much emotion. So in this case, actually, we just use a Vive Pro, and we use the the pupil dilation variance. Actually, that's a good indicator of stress. And trying to figure out, and then kind of trying to figure out also what is a stressor. So in that case, you will get more of that particular stressor later on in the experience. So trying to alter the story slightly based on the pupil dilation things. So there are a couple of standard horror, how they say, kind of standard horror tropes in there. And then we're trying to decide based on the pupil dilation if it's working or not. And what we also tried, I'm not sure if Kirill in the end implemented it, because then the problem was that everything went online, and for the demo I'm not sure, but we also tried a little bit to do an auto calibration for the thermal feedback, because one problem that we have with the thermal feedback with the Peltiers is that it's very user dependent. So depending on, some people won't even feel the coldness, and other people feel it's already too cold, or they feel their hand is burning. So in that case, we use that also a little bit on to try to do auto calibration. And it's just a Vive Eye Pro, so you get the pupil dilation, and we use the pupil dilation variance for the feedback and for stress. Yeah,
I'm not sure if you like have faced any like motion artifact, because like it's in the VR and the headset moves a lot. So like, was there a challenge of like the pupil not being recognized properly or having a lot of noise because of the motion?
So far, I'm not sure. We haven't really. This is this was a VR experience, so we haven't really. I think Kirill is trying to run some experiments right now on the
Okay.
Environment, but yeah, I'm not sure how user dependent it is. It seemed to work. I don't know, maybe other people also have experience, but it seemed to work quite, the Wi-Fi Pro seemed to work quite well, at least for the times when I tried it for the pupil dilation. The other nice thing is, I mean, you have the lighting. I'm not sure about the eye gaze. I haven't worked so much with the Eyewear Pro on the eye gaze side, but because you're controlling the lighting in the VR scene, I would assume pupil dilation should be kind of not so difficult to detect, and over that you can get the stress. But we really haven't done kind of large scale experiments with that and seen how well it works for different people. Maybe now 5 or 6 or 7 people tried it.
Thanks for the response. Yeah, I feel the biofeedback loop is it's amazing. It was interesting to investigate and experience.
Yeah, I would have really liked also to show that actually at SIGGRAPH. It's a little bit kind of how to deal with that is difficult, but yeah.
Okay, great. So if there are any further questions, I think it's best to directly contact Kai later on, or if you could just contact me, I'll forward your questions to Kai later on. So once again, thank you very much for your presentation, Kai, and also thank you to all the participants who joined this session. I'll end the recording now.